Okay, today we're talking about the beginnings of quadratic graphs. And you'll recall that when we have a quadratic function, we know it's quadratic when it has a degree. The largest degree or exponent is 2. And the simplest form of or parent function of a quadratic is y equals ax squared. You'll see that quite a bit. The parabola is the shape of a quadratic function. It's always a U-shaped curve, such as the one that we've pictured here. Things that we need to remember are that parabolas are symmetrical. Symmetrical. So basically you could fold it on top of each other, the two sides match. That fold line that divides the parabola in half is called the axis of symmetry. And we abbreviate that with AOS. And whenever you have an axis of symmetry, it's always x equals some number because it's an equation of a line. And it's this line that goes through the middle of the parabola. That's your axis of symmetry. And so, for instance, this one goes through x at 0. So for this parent function, my axis of symmetry would be x equals 0. You have to write it as an equation of x equals. The vertex is the point on the parabola that represents either the maximum or the minimum value of the function. And basically, it's a maximum if you have an upside down parabola, because it's the highest point in the curve, and it's a minimum if you have the parabola pointing up and it's the low point in the curve. So in this one, my vertex would be right here, and it would be a minimum. And the vertex is always on the axis of symmetry. Now, all quadratics in the form, remember that's our parent form, y equals ax squared. If you're in the parent function, parent form, then my vertex is at 0, 0. Okay, now we can move it around later, but when you're in the basic parent function, your axis starts at 0, 0. So we're going to look at how how the a, the number in front of the x, affects the look of the parabola. And I'm going to start with this first one. And the values that I pick for a parent function would be -2, -1, 0, 1, and 2. Because we always start with our vertex in the middle, and our vertex is at 0, 0. And you pick 2 points to the left and 2 points to the right. We're going to take those and plug them into my x squared. So when I have y equals -2 squared, make sure it goes in parentheses. -2 squared is a positive 4. Do the same thing if I put the 1 in there. -1 squared is going to be a positive 1. Positive 1 squared is positive 1. And positive 2 squared is 4. So for my parent function, I have 0, 0, 1, 1, 2, 4. And then I also have -1, 1, and -2, 4. Okay, so this is the general shape. It's kind of hard for me to do a good job drawing on the iPad, but that's the general shape of a parent function. This is the parent function. That's the base of which everything else is comes from. Okay, the next one I have is y equals -x squared. And when you see the negative in front, I want you to remember that when we don't see a coefficient, it's always 1. So this is like a -1x squared. Go ahead and make the -1 so you don't lose track of it. And my base point is still, my vertex is still 0, 0, so that goes in the middle. 2 points to the left and 2 points to the right. Now, when I plug this in, I'm going to have y equals -1 times -2 squared. Well, -2 squared is a positive 4, so it's -1 times a positive 4, which is -4. So this is a -4. If I put a positive 2 in there, positive 2 squared is positive 4 times -1 is also -4. And what you should start noticing is that these points, these y values, are going to mirror around your vertex. So then when I put y equals -1 times -1 squared, -1 squared is a positive 1, and -1 times that is a -1. And if I put a positive 1 in there, positive 1 squared is 1 times -1 is also -1. Okay, so notice up here, my vertex was 0, 0, and then on each side I had 1 on each side and then a 4 on each side. Your points are going to mirror around that vertex. So the vertex always needs to be in the middle. So to plot these points, I have 0, 0, -1, -1, -2, here we go, -2, -4, 1, -1, and 2, -4. So this one is basically the same shape as our parent, but it's been reflected. Okay, next one we're going to try is this 2x squared. This time I have a positive 2 in front. So I'm going to have the x and y. The 0, 0 is in the middle. So I have -1 and -2, and 1 and 2. When I plug in -2, I get y equals 2 times -2 squared. Remember from PEMDAS, you're going to do the exponent before we multiply. So -2 squared is a positive 4, and 2 times 4 is 8. If I put a positive 2 in there, positive 2 times squared is also 4, and 2 times 4 is 8, so the positive 2 is also 8. And then when we put in the -1, 2 times -1 squared, square the -1 first, make sure it's in parentheses when you put it in the calculator. -1 squared is 1, 1 times 2 is 2. So this is 2 and 2. So I have -1 and up 8, -1 and up 2, 0, 0, 1, 2, and 2, 8. And you'll notice that this one's sort of inside the parent function. Okay, I've got one more that I want to draw. And that's the 1/2 x squared. So again, I'm going to do my table. I have 0, 0. I have -1, -2, 1, and 2. If I plug in -2, I have y equals 1/2 times -2 squared. Well, -2 squared is a positive 4, so 1/2 times 4, half of 4 is 2. So that's going to be 2. And if I plug in a positive 2 squared is 4, and half of that is also 2. Then if I plug in a -1, y equals 1/2 -1 squared. Well, -1 squared is 1, and 1/2 of 1 is 0.5. So this is 0.5, and this is 0.5 because it's a half. So I have -2 and up 2, 0.5, 0, 0, 1 and 0.5, and 2 and 2. And you notice this one goes wider than the parent function. So everything that we did, every time we had an A, it had a different effect on the parent function. And so what we've learned from this is if the A is positive, the parabola opens up, right? Because all of the ones that open up, our A's were all positive. And the vertex is, and remember if it opens up, that means the vertex is at the bottom. So our vertex is a minimum. If the A is negative, the parabola opens down. And if it opens down, that means my vertex is at the top of it, so my vertex is a maximum. Now, the other thing we look at is the number of it. If it's a 1, it's the same shape. Like the one that reflected, it opened down, but it was basically the same shape. But if your A is greater than 1, the graph is going to narrow, get skinnier, right? Because C was the one, the green is the one that got skinnier when I had a 2, which is greater than 1. This is called a vertical stretch, like it's stretching up to the sky. If your A is between 0 and 1, so if we have a fraction that's less than 1, and again, it says absolute value because you're not paying attention to the negative. The negative just tells you if it gets flipped or not. The number, without looking at the negative, tells you if it gets narrow, or if it's less than 1, like we have in D where that was a 1/2, it got wider. The graph, this is widens, and that's called a vertical shrink. I've also heard it called a compression, but shrink works. Okay, so knowing all this, we can look at an equation and know a lot about the graph of the parabola. So for this one, it's positive, so it opens up. This is negative, so on B, it's negative, so it opens down. So the first thing I'm doing is going up, down, up, down. This one's negative, so it opens down. Okay, this is positive, so it opens up. And my last one is negative, so it opens down. So I can tell if it opens up or down just by whether your A is positive or negative. Then the other thing we can look at is whether it widens or shrinks. Excuse me, widens, which is a shrink, or narrows, which is a stretch. So this is greater than 2 is greater than 1, so it's a vertical stretch. the 3 is bigger than 1. Again, you're not looking at the negative, you're just looking at the number. So this is also a vertical stretch. And since the 3 is bigger than the 2, it's actually going to be skinnier. Okay, the bigger the number over 1, the skinnier it gets. Oh, I didn't finish this word here. Okay, so now this next one is a 1. So that means that the shape stays the same as the parent. And I'm going to try to separate these here. Okay. Then on Y, I have a fraction that's less than 1. So this is a vertical shrink. That's the one that got wider. And this last one, this one's kind of tricky. It's a fraction, but if you look at the fraction, it's 3 over 2, which is 1.5. That's bigger than 1. So even though it's a fraction, it's over 1. So this is a vertical stretch. Okay. And that's all we have for today. Thanks for playing.